Hi guys, today we're going to take a look at your review problems for our rational exponent and radical function unit. So I'm on page 22 in your notes packet, and we're going to go through our review problems. For our first section of problems, we're going to simplify each of these expressions, meaning we're going to combine like terms. We want to make sure our answers contain only positive exponents. So for number one, I've got x squared to the second power times x cubed times x to the fifth. I have a power to a power, so that means I need to multiply those exponents. So for this first term, I have x to the fourth times x cubed times x to the fifth. Now that I'm multiplying terms that have the same base, I'm going to combine them by adding their exponents. So this would be x to the 4 plus 3 is 7, and 7 plus 5 is 12. X to the 12th. For number two, I'm multiplying two terms together. So I've got negative 4x squared times negative 5x cubed. I'm going to multiply those numbers, those coefficients. Negative 4 times negative 5 would be positive 20. And then x squared times x cubed, since I'm multiplying things that have the same base, I'm going to add their exponents just like we did for number one. So this would be x to the fifth power. So 20x to the fifth here. Number three, same idea. I just have another variable. So I'm going to start by multiplying my coefficients. 4 times negative 1/2 is negative 2. And then I've got x times x cubed. When I don't see an exponent, that means that it's 1. So I'm going to add those exponents. 1 plus 3 would be 4. So I have x to the fourth. And then for my y's, I've got y squared times y. Again, if I don't see an exponent there, that means it's 1. So 2 plus 1 is 3. I've got y cubed there. Number four, same idea. This time I've got, again, some powers outside of parentheses. Remember that means this exponent applies to everything inside here. So I've got negative 3 cubed, x cubed, and then y to the 3 times 3. And for my second term here, I've got a square outside. So this would be 4 squared x to the 2 times 2 y squared. I'm just going to tidy this up a little bit. Negative 3 cubed would be negative 27. And then we've got x cubed, y to the 9th. And then 4 squared is 16. X to the 4th, y squared. My last step here is to combine my like terms. So negative 27 times 16 would give us negative 432. And then when I combine my x's, I'll add those exponents. So x to the 7th. And then for y's, add those exponents again, y to the 11th. For number 5, I'm dividing now. Remember, when we divide terms that have the same base, we subtract our exponents. So I'm going to do big minus little, and then it will stick where that bigger exponent was. So 8 minus 3 would be 5. So I've got x to the 5th on top. And then for my y's, that bigger exponent is on bottom. So 4 minus 3 would be 1. So I've got y, or y to the first on the bottom. For number 6, I again have an exponent outside of parentheses. So I'm going to distribute that in. If you wanted to, you could reduce these x's first. So I'll go ahead and actually do that. That might make some of my later work a little easier. Remember, when I'm dividing, subtract those exponents. So 8 minus 2 would be 6. So on the bottom, I've got x to the 6th. And then we'll distribute that power in. So this would be 2 squared y to the 3 times 2 over 3 squared x to the 6 times 2. And then we'll just tidy this up a little bit. 2 squared is 4. This would be y to the 6th over 9x to the 12th. No like terms to combine here. I can't reduce 4 and 9. So that's it for number 6. For number 7, again, I've got some stuff inside parentheses to the negative second power. I'm going to go ahead and reduce what I can inside my parentheses here because there's a lot that I can reduce. 6 and 3 would reduce to just 2. And 6 divided by 3 is 2. I've got x to the 4th over x to the 8th. So again, big power minus little power, and we'll stay where the big power is. So 8 minus 4 would be 4. So I have x to the 4th on bottom here. And then y to the 0 is just 1. So I don't have any y's to actually worry about reducing because that top term was just y to the 0. Now I'm going to distribute in this power. So I have 2 to the negative second over x to the 4 times negative 2, y to the 2 times negative 2. If I simplify my powers here for my variables, this would be x to the negative 8 and then y to the negative 4th. Now everything has a negative exponent, so I want to swap their places. Remember, for a negative exponent, I want to move it to the other part of the fraction. So this guy is going to move to the bottom, and these guys will move to the top. Once I move them, their exponents are no longer negative. And the last thing I'm going to do is simplify 2 squared. So this would be x to the 8th, y to the 4th over 4. Now let's talk about some rational exponents. So simplifying again, but this time with rational exponents, not just integer exponents. Same exponent rules apply. So if I look at number 8, I've got something in parentheses with an exponent outside. So I'm going to distribute that to every term inside. So this would be 16 to the 1/2 power, a to the 4 times 1/2, and b to the 8 times 1/2. If I simplify my exponents here, half of 4 would be 2, half of 8 would be 4. And then when I take 16 to the 1/2 power, remember that a fractional exponent is the same as a root. Since the bottom of my fraction is 2, this is a square root. So I have the square root of 16 to the first power. 16 to the first power is just 16. So I want the square root of 16, which is 4. So my final answer would be 4a squared b to the 4th. For number 9, I've got some simplifying to do here with this exponent, and then I also have a term with a negative exponent that I want to move. So 6 over 8 I could reduce to 3 over 4. And then I want to move, again, the term with that negative exponent to the bottom of my fraction. So this would be 4b to the 3/4 over a cubed. That's all the simplifying I have to do there. Number 10, again, I have an exponent outside of parentheses, so I'm going to distribute that in. So this would be 64 to the 2/3 power times x to the 6 times 2/3 times y to the 9 times 2/3 times z to the 12 times 2/3. So the first thing I'm going to do is simplify my exponents here. 6 times 2/3 would be 12 over 3, which is just 4. So I've got x to the 4th there. This would be 18 over 3, which is 6. And then this would be 24 over 3, which would be 8. So I've got x to the 4th, y to the 6th, z to the 8th. And let's take a look at this 64 here. So this would be the cube root of 64 squared. I'm going to throw the square outside of the root. I think that's going to make this a little easier to simplify. The cube root of 64 is 4. And then I'm going to square 4, and I'll get 16. So my final simplified answer here is 16, x to the 4th, y to the 6th, z to the 8th. For number 11, I've got some like terms to combine here. So if I look at my x's, since I'm multiplying things that have the same base, I'm going to add their exponents. So I've got negative 1/3 plus 1/3. And then for my y's, I've got y to the 2/3 plus 1/4. The x's are the easy ones here because negative 1/3 plus 1/3 is just 0. And anything to the 0 power is just 1. So I don't have any more x's here. I just have 1. For the y's, in order to add those exponents, I'm going to need to get common denominators. So I need 2/3 plus 1/4 to have common denominators. I'm going to want to use 12 here. So I have to multiply by 4 on top and bottom for that first term and by 3 on top and bottom for the second. So this would give me 8 over 12 plus 3 over 12, which is 11 over 12. So my final answer here would be y to the 11 over 12 power. If I take a look at number 12, I've got negative 27 to the 2/3 power. I could actually rewrite this in radical form. So so that I can simplify. So this would be a cube root. So I've got the cube root of negative 27, and then I want to square whatever that is. The cube root of negative 27 would be negative 3. And then I want to take negative 3 and square it. That would give me 9. For number 13, I've got 2 to the 1/2 power to the 3/4 power. I may end up rewriting this as a root eventually, but I want to start by simplifying my exponents here. So since I have a power to power, I'm going to multiply. So 1/2 times 3/4, that would give me 3/8. So I've got 2 to the 3/8 power. Now I know that 2 doesn't have a nice 8th root, so I'm just going to leave this as 2 to the 3/8 power. For number 14, 2x to the 2/3 over 5x to the 1/3. I have some like terms here, so I want to simplify. I want to combine those x's. 2 and 5 don't have any common factors, so I can't reduce those, but I can reduce my x's. So I'm going to do big exponent minus little exponent. Again, when we're dividing, we subtract those exponents. So this would be x to the 2/3 minus 1/3. The good news is I already have common denominators, so I can just go ahead and subtract. That would be 1/3. So this would be 2x to the 1/3 over 5. Number 15 is similar to some problems you guys saw on your quizzes. So I've got 2 divided by the cube root of 2. The first thing I'm going to do is rewrite this cube root as a fractional exponent. So if I've got 2 over 2 to the 1/3 power. Now remember that you still have an exponent on this top number. Anytime I don't see it, that means that it's 1. So I have 2 to the 1st divided by 2 to the 1/3. So just like with our x's here, where we subtracted those exponents, we're going to do the same thing here. So this would be 2 to the 1 minus 1/3. 1 minus a third would be 2/3. So I have 2 to the 2/3 power. Number 16, I've got a bunch of stuff inside parentheses here with a square on the outside. You could reduce what you have right now, or we could distribute that exponent through first. Because I don't have common denominators for my exponents right now, I'm going to choose to distribute the exponent through first, but you could also simplify first if you wanted to. So this would be 2 squared x squared y to the 3/4 times 2 z squared over 3 squared x to the 2/3 times 2 y to the 1/2 times 2. So I'm going to go through and simplify my exponents. This would be 6 over 4, right? 3 times 2 would be 6 over 4. And 6 over 4, I could reduce to 3 over 2. So I'm going to use 3 over 2 as my exponent there. On the bottom, this would be 4 over 3 for x. That's 4/3 for my exponent there. And then 1/2 times 2 would be 1 for my exponent on y. So now let's look to combine our like terms here. The other thing actually that I can simplify right now is 2 squared, that's 4, and then 3 squared is 9. So if I want to reduce my exponents, I want to combine my like terms. Again, where I'm dividing, I'm going to subtract those exponents. So I need to do 2 minus 4/3. I need common denominators here. I'm going to use 3. So that means I have to multiply top and bottom by 3 here. So that would be 6 minus 4 over 3, which would be 2 over 3. So I have for my final answer, maybe put my final answer here, I would have 4 on top, 9 on bottom, and then x to the 2/3 on top. And then for our y's, I've got 3/2 minus 1. So again, big minus little, 3 over 2 minus 1. Again, I would need common denominators here. I use 2. So this would be 3 minus 2, which would be 1 over 2. So y to the 1/2. And then this is our only z term, so z squared there. For number 17, I've got, again, an exponent outside of parentheses. So I'm going to distribute it into each piece that I see here. So this would be this off. This would be 9 to the 1/2 power, x to the negative 2 times 1/2, and y to the 10 times 1/2. 9 to the 1/2 would be the square root of 9, which we know is 3. And then I've got x to the negative 2 times 1/2. Negative 2 times 1/2 would be negative 1. So that means I want to move x down to the bottom. So I would have x to the first on the bottom. And then 10 times 1/2 would be 5. So on top, I would have y to the 5th. For our last problem here, I've got things written in square root form. I'm going to go ahead and rewrite them in exponential form. So this would be 16y to the 5th to the 1/3 power times 4y to the 4th, also to the 1/3 power. So I'm going to distribute through that exponent. This would be 16 to the 1/3 power, y to the 5 times 1/3, times 4 to the 1/3, y to the 4 times 1/3. We looked at a similar example in class where we had constant terms with different bases, and our strategy there was to rewrite them so that they have the same base. 16 is a power of 2, so I can actually write this as 2 to the 4th power to the 1/3 power. And then this would be y to the 5/3 times 4, I could rewrite as 2 squared to the 1/3 power. And then y to the, that would be 4/3 power. Now here where I've got power to a power, I multiply. 4 times a third would be 4/3. And 2 times a third would be 2/3. So now I can combine my like terms by adding their exponents. So I've got 2 to the 4/3 plus 2/3. And I've got y to the 5/3 plus 4/3. So when I add my exponents here, I've already got common denominators, so that's good. This would be 6/3, which is 2. So I get 2 squared. And then for my y's, this would be 9/3, which would reduce to 3. So 2 squared times y cubed. 2 squared we know is 4. So my final answer would be 4y cubed. Okay, we're going to pause there and I will do the solving in a separate video.